Now, one other function you can do with the calibrator is actually use it to do calibration. Let's say, for example, we wanted to check the calibration of this transmitter, see how it performs at both ends and across the range. So let's set up to do that. So let's go to Task. We're going to select the task list and we're going to create a new task. And there's a lot of various things you can choose, thermocouples and flow meters, etc. But we have in fact got an RTD, and we're going to go down to an RTD transmitter and we're going to select it. We'll call it whatever we want to call it. We'll set the parameters that are set up for today. It is a PT100. It is degrees C, and it is set to 0 to 100 degrees C. It's a milliamp output, 4 to 20 milliamps, and it's linear. And now we can choose what percentage of tolerance we think is acceptable. So let's say 1%. We can have a number of calibration points, as many as you want, up to 11, and as few as 2. Let's, for the sake of argument, go for 4 calibration points. So this is going to check the performance of the transmitter at 0, at 33.33, at 66.67, and at 100 degrees C. And we've set up that task now. Let's select that. The calibration within the software calibration within the instrument is called ASCAL. We'll select that. And it's set currently to automatically calibrate at each of those points, and we have a 6-second hold time at each of those points. So we're going to select Done. And all we have to do now is hit Start. What you see here is that obviously we have a graph which is going to draw the results, and it will start at 0 degrees C, which will be 4 milliamps. So if I hit the Start, and we see the arrow pointing up, telling us that it's going to do the test first on rising, and then it will repeat the test on falling. So if I go Start, the test begins. Now we move to 33 degrees C. And we can see we're getting a good result. You can see the line is close to the 0 line. Now we're at the 100 degree point. Now you'll see the arrow falling because we're going to check for any hysteresis in the transmitter. At the moment there is almost no hysteresis. The falling graph is almost identical to the rising graph. And back to the 0 point. Okay, so here's the result. So we have a 1% tolerance. The worst error I had was minus 0.2%, and the hysteresis was 0.1%. There was no error at 0, and there was 0.2% error at the span. I could now save that as the as found result, and then I could recalibrate if this was an adjustable transmitter, rerun the calibration and find an as left, and if plugged into the PC I could even produce a certificate based on that.